Aujourd'hui, on ne travaille pas assez avec l'OTAN et en particulier avec le laboratoire que dirige Jean-Guy, qui se trouve à La Spezia, qui travaille énormément sur l'analyse des risques maritimes, à la fois aériens, sous-marins, surface. Il va vous présenter un peu ce qu'il fait. Sachez qu'il y a des programmes qui vont se dérouler sur les 5 prochaines années, en particulier un programme qui s'appelle le programme Maritimo, qui est un programme européen franco-italien, transfrontalier, sur lequel des organismes comme le pôle mer ou l'OTAN peuvent porter des projets. D'ailleurs, ce sont majoritairement ces organismes qui portent ces projets sur ce type de programme. On a besoin de vous pour pouvoir proposer des nouvelles idées et l'OTAN de La Spezia rentre dans le dispositif, donc va se proposer d'être partenaire avec le pôle mer. Je vous propose de nous rencontrer sur le stand si vous avez envie d'intégrer ce programme. Il y a 170 millions d'euros à aller chercher auprès de la Commission européenne sur les 5 années à venir. Je pense qu'il faut pas les louper. Voilà, donc Jean-Guy, je te laisse.
Merci. Bonjour à tous. Tout à l'heure, c'est Madame Pallotta qui fera une présentation plus longue que la mienne. Je vais essayer d'aller très vite, mais en vous rappelant, pour certains, d'autres connaissent bien l'OTAN. Souvent on dit on connaît l'OTAN, oh ben oui, on a une idée de ce que c'est. Finalement, ce que peu de gens savent, c'est qu'après évidemment la Seconde Guerre mondiale, la plupart des centres de recherche de l'OTAN sont situés aux États-Unis. Bon, ben ça c'est une chose très claire. Il y en a un pourtant qui n'est pas aux États-Unis, il est à La Spezia. On partage le même continent liquide, la Méditerranée. Et ce centre de recherche travaille sur tout ce qui est maritime et évidemment sous l'eau. Or c'est assez important cette chose-là parce que finalement 28 nations qui conduisent des essais ensemble, mais on conduit aussi des essais particulièrement pour une nation ou particulièrement maintenant pour des entreprises ou le secteur privé. Finalement, qu'est-ce qui se passe à Spezia? Eh bien, on a plusieurs navires et on est spécialisé dans les essais en mer. Alors, j'aime bien la présentation de ce matin là qu'a fait Stéphane quand on voit des drones. J'ai bien entendu également ce qui était dit par Aldo et tout dernièrement AIS, radar, satellite. Bon, on a des satellites, des microsatellites, on peut bouger. Mais finalement, une analyse à laquelle on pense assez peu pour la surface, c'est ce qui peut se faire en sous l'eau, c'est-à-dire donc finalement utiliser des techniques sous-marines, enfin l'équivalent des techniques sous-marines, ben aussi pour connaître la signature magnétique ou la signature en général d'un navire, reconnaître un bateau de pêche d'un navire un peu plus grand, et puis aussi se dire, on l'a vu, il y a eu des exemples dans lesquels maintenant des petits sous-marins habités de poche près des États-Unis, finalement quand on veut trafiquer, on peut se payer un petit sous-marin et aller se promener. Ça veut dire quoi? Ça veut dire que nous, de notre côté, bon, on a beaucoup travaillé historiquement sur la guerre des mines. Bon, bah ça c'est connu, je veux dire par là, près des côtes, il y a encore beaucoup d'objets et à la suite de différents conflits, on mine des terrains. Mais ceci nous a permis quand même de beaucoup avancer sur le traitement du signal, la reconnaissance, etc. Dans un centre de recherche, qu'est-ce qu'on fait? Bien, on prend quelque chose qui existe, on l'ouvre, on le modifie, on le referme, on le met à la mer et puis on améliore comme ça un certain nombre de techniques. Bien sûr, je fais un petit résumé, mais comme ça au moins ça vous permet de garder en tête le principe. Trouver une mine, c'est bon, c'est pas très simple. Quand c'est dans le Poséidon, par exemple, il faut arriver à analyser des objets. Pire que cela, si vous avez du sable et que ce sable a bougé, arriver à retrouver les petits objets là qui sont placés en rouge, ouais, bon ben c'est pas courant. Par contre, ça aussi, ça peut servir le jour où il y a du trafic, parce que un trafiquant va peut-être lâcher de son bateau un certain nombre de choses et le mettre au fond de la mer. Évoluons encore un peu, si jamais vous avez aussi des objets au travers de rochers au fond de l'eau, ça peut devenir compliqué. Alors bon, tout un tas de techniques, je ne vais pas rentrer dans le détail. Bon, pour la chasse anti-sous-marine, bon, eh bien, on a fait pas mal de choses. On parlait à peine du projet Perseus, on a participé aussi à ce genre d'aventure. Bon, disons que le centre est très ouvert aux collaborations. Alors, on a parlé, d'accord, de quoi? Eh bien, de l'environnement, de la connaissance de l'environnement. Donc, on a des programmes avec des gliders, voilà, c'est ça, les gliders, donc qui arrivent un petit peu comme des planeurs sous l'eau, à repérer quoi? Eh bien, à repérer et à ramener à des centres de commande des données telles qu'à température, salinité, densité, la vitesse du son. Bon, là, je parle comme quelqu'un, évidemment, avec une auréole. On peut trouver beaucoup d'autres choses, mais qui sont beaucoup plus discrètes et beaucoup plus confidentielles au niveau de l'état de la mer. Tout ceci, eh bien, a été présenté, vous l'avez vu dans les présentations précédentes. On a des données de plus en plus importantes parce qu'on arrive à concaténer à la fois des prévisions, des prédictions et des données. Moi, j'aime bien une chose. Avant, on parlait de kilo-octets. On a commencé à parler de mégas. On parle de téra. Bon, nous, on a plusieurs pétas de données, c'est-à-dire donc plusieurs milliers de terabits de données. Bon, ça commence à faire compliqué, surtout qu'il faut les ranger, surtout qu'il faut les organiser, les classifier. Donc voilà, toujours ce même principe, environnement, performance, décision. Alors, le sujet que va traiter Mme PALLOTTA, eh bien, traite de la sécurité maritime et de la fusion de données. Bon, on en a parlé, hein, l'environnement, c'est 90% du marché. Et elle va essayer de vous montrer comment elle analyse et elle extrait des anomalies. Bon, alors là, c'est vrai que c'est tout un art, c'est un peu compliqué, mais enfin, elle a l'art de la vulgarisation. Elle saura vous expliquer tout cela en long et en large. Voilà un petit peu ce que l'on fait à la Spezia, c'est qu'une image. La Spezia, c'est une épice. Eh bien, j'essaie d'un peu épicer la présentation qui va venir avec cette petite présentation. Merci de votre attention. Je lui passe immédiatement le micro et comme ça, vous pourrez aller déjeuner à une heure raisonnable.
So, first of all, I'm sorry if it would be in English, the presentation, but Angela will be there in case she will save me. So, we've seen in the last presentations that big data challenge is the new challenge, it's new opportunities, but it's also a lot of work in terms of new algorithms to be developed, new sampling techniques and approximations to get some real value from this huge amount of data. Actually, yesterday, this specific maritime security strategy plan, which was issued by the European Council last June 2014, was published, and that in some way opened new opportunities even for collaboration with NATO and other European institutions, because there was a specific highlight on pooling information, sharing information, multilateralism, as well as a good coordination with the other institutions and research centers, as specifically in NATO. We know that in order to achieve this global maritime situational awareness, we need to, let's say, collect and summarize this huge amount of data from many different sensors. It's an open problem because it's not such an easy task. And also, the way forward is to make that kind of knowledge we are able to extract and learn useful and actionable, as we were listening in the first video that Stefan had shown us. So, because the final aim will be maritime surveillance capabilities and anomaly detection for sure. These are the kind of sensors we are using at the center, and these are the kind of data we need to deal with. So there are AES data from coastal receivers, long-range identification and tracking system data, VTS, SAR imagery, synthetic aperture radar systems, high-frequency radars, active and passive sonars, satellite AIS, and environmental data. And those data all contribute to create this refined picture. One way to, let's say, get some knowledge from this huge amount of data would be, for example, to derive baseline patterns of life, starting from specifically satellite and coastal AIS radars. And this is a kind of application I would like to share with you because it's something we are developing now at the center. So actually the tool we developed is called the TREAD, Traffic Route Extraction and Anomaly Detection. Basically the idea is to start from raw data, process this data, clean up this data, and derive these, let's say, synthesized routes, which in some way are models for behaviors at sea. As you can see in the bigger figure, one way to, let's say, represent these patterns would be in terms of specific patterns, but also it would be like including other features like the number of transits along the routes as well as the average speed observed along the route, because all these things will contribute to, let's say, create new ways to highlight anomalies at sea. Another way, we've seen this morning, it's a kind of hot topic, how to derive stationary areas, which could be either stopping areas for vessels, which could be either, let's say, areas where vessels were loitering. That's another activity we are involved in. And this might, of course, again, highlight some suspicious behaviors. The way we represent the route is in some way very simple. There are many algorithms behind though, because we try to clean up the models we've derived in terms of behaviors of vessels, highlighting first of all outliers which don't comply with the derived model, and then from those models derive some suspicious behaviors. This is an example using just the satellite AIS data, which are the most challenging ones because they have some problems with timestamps and revisit times of satellites involved. And this is a very wide area, the Atlantic Ocean. So what you can see is how the summarized information can be represented. This would be a possible way, so KML files where even though the area is very large, we still keep granularity of the local traffic in terms of local routes compared to transit routes and transoceanic routes. Now I would like to share with you, let's say, some project we were involved in, which exemplifies this, let's say, the different tools and products we've developed. First of all, we were involved in this action sponsored by COST, which is a cooperation in science and technology, a European initiative in 2013. And what we've done is we've processed data provided by the French Naval Academy, and these data were then clustered and created a behavioral model for the specific area. This specific, let's say, model could be even used to be compared with the real-time traffic data. So in some way, we can, let's say, suggest a baseline to highlight suspicious behaviors of vessels based on what we've seen in the past. What's the historical image for the area? This is another video we've prepared for another project, which exemplifies this again, how on a very bigger area compared to the previous one, the Brest area, how the real traffic compares with these synthetic routes. Each route let's say, is an example of a different behavior. So for each route, we have some summary statistics I'm not showing you now, but it's something behind this model, and this helps in highlighting what's different compared to what we have learned from the past, from historical data we store at CMRE. Another study we've done is for the U.S. Coast Guard. Basically, what we were doing is we were deriving the historical traffic in the area because they wanted to plan the design of new offshore wind platforms. So they wanted to create a system which, in some way, wanted to measure the impact of these new structures at sea, so the risk of collision of vessels in the area. And the historical traffic was used to create a sort of model of what would be the impact of the new structures and how these structures should be located to minimize this risk. And again, this is a very important thing, I would say. The stationary areas which were derived, the very yellow square picture, these stationary areas were derived just using satellite data in an unsupervised way. And so that would be a way to compare and contrast with other contextual information we can get from other sources. So they could be fishing vessels, there could be loitering vessels, and also these can give us suggestions about the specific bathymetry of the area, which was something that yesterday was shown by Kenneth Eatmuth for the specific application he was developing. Another project we were involved in is the European Commission FP7 project NERAIDS, where we assessed the challenges in integrating space-based information into surveillance capabilities. These were the partners, and basically CMRE contributed to two main tasks: to create this multi-source data fusion module and to ingest this historical information to enhance route propagation and route prediction in specific areas of interest. One area was, for example, West Africa. There was an NERAIDS West Africa data campaign, and in this case we've derived the behavior of vessels in the area, and for each route we can drill down some more information, as we were saying before. So we have information about the duration of transits along the route, the distribution of the heading of vessels, as well as the distribution of speed over ground. This study, which was within the same project, was done jointly with the Joint Research Center. So we were combining the non-cooperative capability of synthetic aperture radar images with the AIS data. What we were doing is we were comparing these SAR detections, you can see on the left, with the derived knowledge about the historical activity in the area. Because in some way we were able to, first of all, highlight ship-to-ship transfers or kind of very, let's say, quick exchange of, we don't know exactly of what, between ships, but that was a way to highlight some suspicious or illicit activities in the area. And also it was a way to highlight black targets, because SAR images gives us the opportunity to highlight something we cannot see always with AIS information as well. Another application was, okay, this is a very hot area, Gulf of Guinea, also for piracy activity. We know it's the new area for piracy activity. And in this study, what we were doing is we were correlating the historical routes with the pirate attacks in the area. Because in some way, this will give us indication of what kind of routes would be in some way more risky to transit for vessels, or how we should modify some of these routes to avoid the pirate attacks in the area. Again, one interesting activity now is to monitor fishing activities. And one of the last data campaigns that NERAIDS performed was in Norway to monitor and to study and to model the behavior of fishing vessels. In this case, the study was done to, first of all, let's say, create different information layers for different ship types. So in this case, you can get passenger, cargo tankers, fishing vessels, and correlate this information with, first of all, SAR imagery we had for the same area, as well as with the traffic density map you can see overlaid in this slide, which is a heat map, and you can see where the vessels stay longer and where the vessels are most in this specific area. one possible way to, let's say, fuse this information is through the development of some association algorithms which try to correlate these SAR images with the AIS tracks. Because, again, in this way, we are able to, let's say, reduce the number, shortlist the number of vessels we should investigate, because there might be something wrong, because we are not able to associate those vessels to any of the tracks we are already seeing in the specific area. This is just a screenshot of the system we are developing at CMRE. It's a viewer, an MSA viewer, where you can even visualize raw data, so real-time data, but also fuse the tracks. So you can apply algorithms and create these fused tracks which can be visualized and compared to real traffic. One way, let's say, to in some way reduce problems, so we've seen this morning some examples of this, is to in some way reduce and clean up the data we are ingesting to the system, because there are many inconsistencies in the data. We are at CMRE processing billions of data per month, and with fusion algorithms we are able to clean up the image, and this is very useful in order to ingest then this data to the thread system to create patterns of life. The concept behind the MSA viewer is a sort of a shared platform where nations can, let's say, test their algorithms without sharing their data, which is something very useful in case we are not able for all the nations to, let's say, to guarantee this sort of data exchange. Of course, we've seen at the beginning we don't just process AIS data. These are acoustic data, and these are screenshots for, first of all, one is from Proud Manta 2013, which was an exercise performed by CMRE. And in this case, we exchange now. We've seen how the fusion of the acoustic data can be even performed using specific algorithms, as well as using HFSW radar, so high-frequency surface wave radars, which were first designed for environmental application, but then it was seen they were very useful to detect the vessels as well at sea. So we are doing this kind of application as well. We've done an exercise in 2013, there will be another one the next year, about port protection, which is another activity we are involved in. So basically applying the data fusion algorithms we've seen before real time to detect a possible menace, a possible threat to a specific harbor, for example, a high-speed rubber boat who's coming in the harbor, and that was another study. And we've spoken yesterday about interoperability, how we can test and guarantee interoperability. One possible, let's say, test was for us CWIX, which has a very complicated acronym, so Coalition Warrior Interoperability Exploration, Experimentation and Examination Exercise. So the idea would be like the nations come together and each of them has specific algorithms they want to test, and they want to do this exchange, which is not really an exchange, as I was saying before, because they don't share data, they don't share algorithms, there's a black box, but they can provide an input, and another nation or another center like us can provide them an output based on the input they are providing us. And this year we will test thread within CWIX. The last thing, another example of a data-driven system we are developing at the center is based on the sensor performance estimation, because this is a complementary thing to the historical information we can get about vessel movements. We need to be sure that when we get data, it's a sort of reliable data, and we need to be sure that in case we don't see vessels in a specific area, this means that there are no vessels there. there. And it doesn't mean that the sensor is not able to, let's say, catch or detect a vessel in a specific area. And with this system, we are able to compare and in some way reduce the number of dark targets as well. Because as you can see, coastal AIS receivers are not able to have a specific range. And even in an integrated network, there are some black holes. And this would help us also to, let's say, to design and to place new sensors in the right places to be sure that we are able to detect vessels in a specific area we are interested in. So, current and future activities. Of course, one possible way to exploit TREAD tool would be like to, first of all, increase its level of automation and scalability, but second of all, is first of all to, let's say, to perform destination estimation, which is something we've seen before. Something was published, but something else, it's ongoing now. So how we can, let's say, estimate the probability that the vessel will be at the specific destination, given that he has declared a specific destination. Because what we've seen in our database is that, for example, the destination field in AIS message is one of the less reliable information that vessels provide, because it's not one of the compulsory ones. So sometimes they forget, let's say, to change that information. And with this system, we are able to, let's say, give a probability that the vessel will be in a specific port or in a specific area. Also, another way would, another study we are doing and we want to continue is about simplifying this network of traffic network at sea. Because similarly, for example, to the London Tube map, what we would like to do for specific application is to provide a very simplified image of the traffic. In terms of a graph, a topographical map of the traffic, as it happens for roads and for cars. And the last application, which is maybe the most important one, is to classify new tracks that come in once we've learned something from the past. So this is a Bayesian approach which was presented in the papers listed below. But basically the idea is to provide a score which gives you an immediate idea of how that specific vessel is behaving in a kind of different way compared to the past. Let's say we don't still know if it's illicit, illegal, anomalous, but we know that it's something we've not seen before. The last application was presented in Salamanca in 2014, July, was how to use these patterns of life to improve the accuracy in prediction of vessel positions and speed. Because once we have this image and we are able to translate that historical behavior into specific, let's say, vessel motion models, this can be used to provide a better accuracy, so a better precision in terms of errors we are able to, let's say, accept for the prediction of the position of vessels at sea. And it's a study which was presented, as I said, last July, but it will be presented again at Oceans the next year to the new conference to, let's say, demonstrate, because that's the title of my presentation was how to, let's say, make a productive use of this kind of information to improve estimations and decisions. And this might be a possible way to use that kind of information. So this concludes my presentation. This is my contacts. Of course, you can contact Professor Zhongyi or me in case you have questions or specific, let's say, questions now or questions even later, and also if you have if you want more information about what we are doing at the center. So, thank you.
Bien, écoutez, je vous remercie beaucoup d'avoir assisté à notre présentation. Je pense que le message principal de cette dernière présentation, c'est de rester aware Vous avez vu ce que fait l'OTAN sur ces analyses. Il y a beaucoup de choses qui sont très intéressantes et sur lesquelles je pense qu'on aurait beaucoup d'intérêt à travailler avec eux. Aujourd'hui, on ne le fait pas assez et je reviens là-dessus. Il faut absolument que vous preniez contact avec ce laboratoire et que vous repartiez avec leurs coordonnées pour leur proposer de travailler sur des futurs projets. La France participe à l'effort OTAN au travers de l'acte tous les ans, avec un budget que nous offrons, on va dire, à cet organisme qui achète des études, qui achète du matériel, mais qui n'achète pas souvent français. Et nous avons la chance d'avoir des Français qui travaillent dans ces laboratoires. Je pense que voilà, il faut prendre leurs coordonnées et voir comment on peut travailler dans l'avenir un peu plus avec eux pour valoriser ce qu'on sait faire. On a des choses à apporter, on a des choses aussi à aller chercher. En particulier, toutes ces moteurs d'analyse qu'on vient de voir, qui fonctionnent déjà avec des analyses de données très performantes sur des pétaoctets. Vous avez vu hier, pour ceux qui étaient là, des analyses que fait actuellement Google pour le monde de la pêche. Je pense que les gens ne se doutaient pas finalement que Google était déjà en train de travailler sur ces domaines. Il faut aller gratter et chercher un peu ce qui se passe chez nos amis américains. On le fait pas assez souvent. Voilà, ça sera la conclusion de ma présentation. Merci encore d'avoir assisté à cette session.